Doctor, I think you're muted.
Okay, so sorry, I was muted. Let me share the screen one more time. So as I said, I was happy of what I have seen in the breakout rooms. Oh wow, that's nice. I was happy of what I have seen in the breakout rooms. People started to think in the right track, and here we will try to highlight the main differences. Let's move step by step. I'm gonna open a new script, and I'm gonna put this on the side here. Let me save this and call it, how should I call it? Finite sum, but with a while loop. And that makes it a little bit tricky, as you will see. So you can write a comment as always. This code calculates a finite sum using a while loop. And we started with sum equals 0, as we have seen before. And we also started with the true value equals pi power 4 over 90. Then if you look here on the right, there was a for loop, but I want to replace this with a while loop, right? So there is a while loop, and that has to end somewhere. I think when we put while always true and put the breakage condition inside it, that could make the programming a little bit easier. So in fact, I'm going to put while 1, and I will put the breakage condition in the middle. So let's innocently try to say that sum equals a sum plus 1 over k to the power 4, as we did in the for loop. That's what we did here in the for loop. The problem here is that you do not have a counter k. The for loop was very nice because it provided you with a counter k, which you could have used in summing the series, but here you don't have it. If you don't have it, just create it. How do I create it? Let me start here at the beginning by defining k equals 0. That's as an initial value. And please learn this trick. If there is no counter and you want to create a counter, that's how you do it. It's a trick that you can use in all your programs. So now inside the loop, I'm going to say that k equals k plus 1. Now the k is going to keep incrementing. Every time the while loop cycles, the k is going to increase by 1. And this way, I can include it in the sum calculation. Even more, I can, oops, what do I have here? Even more, I can actually use this k as an index for the array error. In fact, I'm going to do this. Let me actually copy it from here just to save time. It's this big calculation. Copy and paste it here. Error of k equals the absolute value of sum minus true value over true value multiplied by 100. Now I should put my stopping criteria. So I have 2 comments on this break condition or stopping criteria. So if, and I need to put a break, then I have break, right? And what is the condition? If the error is error of k is, some people said, if it is greater than 10 to the power minus 7, and just a small comment here, 10 to the power minus 7, 10 to the power minus 7, in MATLAB syntax, it can be written as e minus 7, 1e minus 7. Please learn this. If you want to learn, for example, how to write 3 times 10 to the power 5 in MATLAB, it's going to be 3e5. Okay, that's a short way to write it. So if the error is greater than 1 times 10 to the power minus 7, then stop. Guys, this is gonna stop after the first cycle. This doesn't work. Why? Because if you remember, after the first cycle, the error was 8%. And if you are saying if the error is greater than 10 minus 7, then break, it is greater than 10 minus 7, because in the first cycle it's 8. And this is like 0.00001, right? So that's not the stopping criterion. The stopping, if the error is less than 10 minus 7, then please break. Okay. And by the way, also one more thing, this is the error after we multiplied by 100. So you don't need to bother about multiplying by 100. So that's actually the percent error after we multiplied by 100. Okay. Now, another issue that I found is that some of us, let me cut this, some of us put this break condition at the very beginning of the while. There is a big issue here. What is the issue? I haven't defined the variable error yet. I don't have a value for it. Like if you are telling MATLAB, hey, compare error with this thing. Well, you haven't calculated error yet. Because of this, this condition has to appear after you calculate the error. Okay, so because of this, I need to remove it down. So let's take this, cut, and put it here. Okay. Now I'm done. Now I really managed to store in this array the values of the term, the values of the error, all of them that have value greater than 10 minus 7. Because if it's less than 10 minus 7, I'm gonna break. Okay. All right. So one more thing. In the for loop, my x-axis, I knew beforehand that it should have 100 terms. And that's why I automatically put the variable number of terms equals from 1 to 100. But here, I don't know how many terms I have, right? I really don't know how many terms I have. Because of this, I need to define the variable number of terms inside the while. In fact, let's test it just, so that people understand what do I mean. Because sometimes if I say it without testing it, nobody understands me. So I'm gonna naively take this block here and try to plot. I'm gonna take this block here, copy, and let's make this bigger now. I'm gonna naively try to, and please notice that this end is related to F, while this end is related to Y. So let's try to naively plot here. Let's run. MATLAB is not happy. Why it's not happy? Because it says vectors must have the same length. What are the vectors that don't have the same length? Let's see. The number of terms contains 100 terms, right? Because why 100 terms? Because I already defined it from 1 to 100. But look, I am plotting it with the array error. What is the size of the array error? It turns out that the array error contains 607.75. So it's much larger. Why this is the case? Because the number of terms needed to reach to this small error is actually 675 terms. So that's why the size of the array number of terms does not match the array error. How do I make them match? Well, you need to define the number of terms inside the for loop in terms of A. So number of terms of A equals A, right? So when K starts as 1, so first of all, before the loop, it starts as 0. Inside the loop, it becomes 1. Then I calculate the number of terms of 1 equals 1. So that's the first term. And it's going to keep looping until when the loop stops, the last number of terms is going to be 675, right? This way, I managed to systematically trace how many terms do I need. Okay, let's do the plotting now. I think we can safely plot. Let's run. Oh, there is something that I made that types stuff on the screen. Of course, we will look at the plot, but I want to suppress this. Yeah, I should suppress this guy from writing to the screen. So save, run again. Guys, I hope you can see Where did it go? Yeah, it's here. I hope you can see now that we needed more terms to reach to such a small error, right? To reach to 10 to minus 7, I needed to go to 675 terms, right? So I need a lot of terms to achieve this. And thanks to the log scale, it makes me see clearly how many terms do I need. You can try to play with this code and test how many terms do you need if you make it 10 minus 8. You can run it. Wow, you need almost like 1452 terms to reach to such accuracy, which is 10 minus 8. If you want to exhaust this to a very, very, very high accuracy, how many terms it takes? It takes a crazy number of terms, 6,000 something. So this code can be used for exploration purposes to see how this series converges, right? You can keep playing with the accuracy that you need and see how many terms it runs. So although while loop is a little bit roundabout, but it's beautiful in terms of exploring the convergence of certain series. Okay, I'm gonna stop here and see if there are any questions from the participants here or the shadow meeting. Any question here?
We are okay in the shadow meeting.
All right, perfect. Oh, there's something here in the chat. Can't we make the number of terms to be from 1 to k? Oh, that's a beautiful question. Well, or does it have to be an integer? Let me answer the second part. Well, k is an integer, so no worries about it. I really like this one, Hannah. And yes, it is an integer, so no worries about it, because remember, k starts as 0, and I systematically add 1 to it, okay? So in fact, what you suggested can work. Let me apply it. So what your colleague is suggesting is just don't put this inside the while loop. In fact, outside the while loop, write 10 terms, number of terms equals from 1 to k. Yes, because the last k is gonna be 675. Well, if we go back to the power minus 7, it's gonna be 675. And because of this, the last k is stored in the memory. Okay, and let's actually try to do it. Let's run this. Oh, there is a tiny issue. I think I know what is the issue. Let's see. K is 607. Why? I think I need to clear the memory somehow. There shouldn't be an issue here. Did I? Okay, I didn't clear the memory. Guys, this is a good lesson for us. I should always type CLC and clear all here, because I didn't clear the memory. So it's still preserving the old error array, which is huge. It was like 6,700 something. So let me save this and run again. Now it runs. So your colleague's suggestion, instead of putting the number of terms inside the for loop, the while loop, you could have put the number of terms outside the while, relying on the fact. So let's write a comment here. I know that A is adjusted to the correct value here. And maybe I write a comment here. This is an alternative way to define the number of terms. And I will leave the one that your colleague suggested, because it's also a very clever. More questions. Let's save this. We don't want to lose it. Yeah. More questions or comments. And thank you for this one. That was actually very illuminating. Any other questions, guys? Okay, so we are done with loops. Next session is gonna be on functions. extremely important session because it shows you how to develop modular code. Modular means you have pieces of code, each one of them is doing its own job, and then you compile these pieces together or call them from one script. So next session will be extremely important, and we will be using in it applications from if statements, from for loops, from while loops. Okay, so please try not to miss the next one. I'm gonna stop and thank you guys for attending here and in the shadow window. And also thank the ASME students for their excellent effort in coordinating this event. Let me stop recording here and